All right, so in the last section we had we're going over the details of the scene and the scene objects, component objects, how they relate to each other, and that assets are uh, files on permanent storage on the file disk, but they're not in the project. They're loaded in as objects, usually as component objects. So um, just so you know that all these components, all these component objects are actually C# objects. They're just fancy. They were created by Unity developers. They got nice icons, but behind the scenes, this set of functionality is a C# class that was sitting on a file. It's just not shown to you and copied or instanced as an object. And we're going to create our own custom functionality, and that's what our C# scripts are down here. So that's why I had you just right click, create C# script, and just name it something. Just don't leave it as the default name. Now we're going to start diving into the code, and we're going to start diving into what C# is. Think of as one script file is like one class, and a class is like a blueprint. It's like instructions for how to create an object, an instance of it in your app at runtime. You can have many objects spawned or created from a class. So a class doesn't live in your app. It is just a blueprint that sits on your file system and then it's copied into your app at runtime. So these are objects, and somewhere sitting out, somewhere is the C# equivalent, C# script of these. And the same for this one here, like this camera object, component object, this audio listener component object, this transform component object. It is just a copy of a C# class. So if I double click on this C# script I just created, this is like the boilerplate, the template C# code that comes along for the ride. Most of it you use, some of it not. Interesting that these are actually not supposed to be white. I'm just clicking through. These are other scripts in my project. And notice that in Visual Studio, when you click on a script, all the lines of code are shown, and there's like a number for each line of code. It's very easy to move around and reference. And code gets colored in different ways. And I'm going to go through what all these different parts mean. Oh, there we go. It just took, I was waiting for these to not be white. So good. It went through and it registered the code, and it's using IntelliSense, and it's coding your stuff for us because everything's connected up. Now, up here is the name. So I just created it. I called it sample2.cs. This is living in our Unity project. If I hover over it, you can see its location. It's just we're opening it up, and Unity is kind of controlling Visual Studio and making for an easy way to write the code. This script file you see has 19 lines of code. And if we start at the top, we see that there's a bunch of using statements. So using is a keyword. The keywords for C# will be shown in blue. They're like reserved words. You shouldn't use them in your variable names. And these are saying we're using, and as I hover over it, it's using a directive or it's using a namespace. These are basically external libraries of code that have already been written for us, and we're trying to reference them. These system libraries were written by Microsoft, and these are for the operating system. I happen to be on Windows, but if you're on Mac or Linux, the corresponding system library is named the same, but it would be particular code to use with that operating system. You can access different parts of your operating system, but this is just saying, hey, in this namespace of system, it's just a way for it to like reference, like, wait, which code are we talking about? And a namespace is just like an organization system, just like your folder system is, just like HTML or HTTP code like www.google.com. It's just a way to organize a name so it knows where to look it up. So this is saying I go to the system namespace and dot, this is called an operator. And there's a few scattered in here that we'll be introduced to, but the dot operator has to deal with classes and objects. It is a member operator. It is saying go into the system namespace, and within that namespace, go to the collections class or namespace. Within the collections namespace, I should say, are further classes. Right now it's grayed out because we're not using it. But within there, you might find data structures or data collections that are known in computer science as lists or linked lists, arrays, maybe even stacks and queues and trees. And these are more advanced concepts. We're not really going into them, but just know that these using namespaces are here because it's often the case that a game programmer might make use of these collections. So it's already listed there. But since they're grayed out, we're not referencing them. We could delete them if we choose to. Using Unity Engine is highlighted, and it is actually used. So we're using a library of code that's coming from Unity, and we're referencing it with this kind of type of key name. So notice that each of these are lines of code. They're called command lines. And when you finish a line of command and you're done with that statement, you have to end your line with a semicolon. So if I just take the semicolon off, a few things to note. This like yellow thing appeared. It's like a highlighter. It's trying to tell you that you've changed something. Something was modified. Notice that my file name up here has an asterisk on it. It means that we've changed this file. It's dirty. It needs to be saved out if you want to save your changes. And notice that there's a red squiggly line. This means that there's an error. And also over here, this is really convenient. As you start running more lines of code, you'll see there'll be like all these kind of like dots. This red one, if I move off it, if I move down here, notice that this white dash, as I click around, represents where my active cursor is. And this red dot says, hey, you have an error in this line of code. And also this line is modified. It's got that kind of yellow marker. Well, the error, if I hover over it, says expected a semicolon, basically. It says semicolon expected. Well, that's because this is a line of command. And for each little line of command you write in C#, you have to end it with a semicolon, and the compiler knows that it's a complete statement. We're done. Now, moving down here is the big class, the major part of the code. One class per script is how we're going to function. It's simple. It's straightforward. Notice that the class name is the same as the file name. That's why I said it's important that when you create a C# script for the first time, don't just use that generic name, because you're going to end up changing it. And that when you change it, the file name will now be different than the internal class name, causing an error. And then you have to go into Visual Studio and change the class name. To make it easy, just change the file name right away. So what do we have here? Public class sample2. So sample2 is the name of the variable. We're making a variable of type class, and it is public. So public is an accessor. Notice these are in blue. We have public, private, and protected. By default, you want to aim to make as much of your stuff private, and that's what's known as data encapsulation. Private means other classes, other objects from other classes cannot just come in and access whatever it is that's private. Public means other objects can access it. So this is saying this is a public class. That's important at the top because Unity does access this, and you will also access this object openly. So just note that it's public, it's a class, so any objects created from this class in our app at runtime will be public. We can access them from other parts of our code. Now we name it so that we can reference it later. And note that this is another operator. This is called the inheritance operator. This is saying this class that we're creating is inheriting all the code from MonoBehavior. MonoBehavior is another class. but it's coming from the Unity engine namespace. It was written by a Unity developer. And it's basically every script we're writing will be inheriting mono behavior because these are functions that are going to make our script work within the Unity engine. Now note that there's a curly bracket here that opens up our code. This is all the code, our code block for that class. And this ends our block of code. For classes and other things, which I'll cover later, you need to specify an opening and closing. This specifies all of our class. I can close it up and open it back up. Up here is just like some nice hints that come along when you connect up Unity and Visual Studio. This is just saying that there's a Unity script. And as we make more scripts, you'll see like there's other scripts referencing to other parts of this. And this we're going to cover later on. Now, a class sits on your hard drive, and when you connect it up as a component object in Unity, when you click play, when you run the app, it's going to say, oh, I have to create objects of this type of class. So as we go into this code base here, the first thing I'll look at is this start method. Classes and the corresponding created objects that are actually live can have methods and properties. Properties are like variables. There's none here right now. I'll create one later. And methods are functions. You might have been exposed to functions in your other classes. A function is a block of code that's really useful to define with a name and say you can call it many times over, and you don't have to like rewrite your code a lot. So a method is just a block of code in your class that you can call over and over. You can also understand that it's a method because of the structure of it. You have this name, and then you have these kind of smooth parentheses, these smooth brackets, and there's an open and a close. Right now they're empty, but if you did have some type of input that will be sent into your function, any input data, they're called parameters. They will be listed here, which we'll see in later methods. Also to the left is the return type. This is of type void. It does not return anything. It just executes code. But you can return any other type. A type being an integer, a float, which is a decimal, a Boolean, or other types of objects. And a method needs to be defined within a code base. So here's the beginning and the end. Right now there's no lines of code in it. Now the start method, as written up here, is provided to you from mono behavior. It's inherited, which is why we're inheriting from mono behavior. And it is called on the first frame, meaning when this object is instantiated in the app at runtime, when it first is created, the start method is run once, right at the beginning. So it's really helpful for initializing anything. Speaking of what's up here, this double / is called a comment. This is not functioning code. This is just notes to yourself or other developers to help you remember what was happening in your code. Another symbol that you can use is the multi-line comment. It starts off with this, and you, however many lines of comments you need, you just press the enter key, and then you end it with a /. Now all those 4 lines are just comments. You can write stuff here. All right. And notice it says it's a Unity message. Again, these are like little helper texts that are coming in. It's a special type of method that we're inheriting. Now here's another comment, and it says, hey, the update is called once per frame. So now we have another method, void update. Usually methods in I kind of should have uppercased this, but usually methods and classes have an uppercase. And again, here's our input. You can see that there's a method and a block of code. Nothing in and nothing happening, and nothing's coming out. An update is like, it's called, this method on all of our objects are called as many times a second. It's called all these are called what they call a frame. It's like the code in your game or app will run as quickly as possible, depending on how much code is in it, depending on what type of computer it's running on. And as quickly as it can, it will call this update method. It can be 30 times a second, it can be 60 times a second, 100 times a second, just depending on how complicated your program is. But it's several times a second, usually 30 to 60. You may have heard of frame rate or frames per second. Things that might get updated in here are the graphics, which you can see the frame rate, or when you have to check for user input or run logic that can change frequently. You'll write stuff here. Now, one thing I should note is that these are by default private. When something is not declared public or private or protected, it will be by default private because we worried about data encapsulation. You can write your own method. I'll say private void my method, smooth brackets with curly braces. All right, this is how you can write your own method. Now, what I wanted to show you was that we can put some debug statements in here. And this is the first time we're going to connect up with Unity and actually run our code. For those of you who are entering, our last class had a fire alarm, so I'm running late. So just please ignore me until 2:30. So I'm going to type debug. And notice it gets that color. This is a type of color saying it's coming from the Unity engine. Debug is a class that's going to help us debug our game. So I'm going to use the dot operator because I'm going to go into the class and I'm going to call the log method. We can log stuff to our console. We can display messages to ourselves. So what we see in the little help here is that it's debug is the class, log is the method. It's expected to receive an object and it's going to print, or it's going to return void. So it can really receive in anything because any object has some type of toString method to it, converting it to a string. What is a string? I'm just going to put in a hard-coded string, the basic hello world. So notice that there's double quotes surrounding this. It's what's known as a constant or a hard-coded value. And right now it's just a string. Notice that there's an error because I don't have my semicolon ending my line of command. And a string is text that humans can read. And it's just a string of characters. In this case, it says hello world. Now I'm going to write that into our start method. And I'm going to pop over to Unity. And I'm just going to create an object just to put it on. I'm just going to create a sphere. And now I have my game object, which has a bunch of components on it. I'm just going to minimize them so we don't look at them. And this is my C# class. This is my code. The class isn't live in our app. But if I drag the C# script, the class, onto the object in the inspector, it'll create a component object. It will instantiate that class as an object, a component, an instance, a copy of that class is now going to live on our sphere game object. I'm going to go to the console. I'm just going to clear out these warnings that they have to deal with other code that's sitting in the project. And we have now an instance of this class in our game, in our app. And I'm going to click play. And notice in the console, we have a printout to us, the developer. At this time, the string hello world came through. And it was coming from the Unity Engine debug log class. And here's the details of it. And notice that it's being called from the sample2 C# class in the start method, which ran right away. Start method runs right away when you click play. And here's the actual location of the line of code. This is from last class. Ignore me for a few minutes. And if I click on it, it goes to the line of code where the debug was. This is really useful when you start printing out your variables, trying to figure out where in the code things are breaking. Awesome. So we printed a text. We printed a notice to us in the console. So I'm going to unclick play, clear out the log. Now I'm going to move this over to the update and save it. Start runs once right at the beginning. Update runs as many times as it can for as long as we're running the app. So I'm going to clear out the log. I'm going to click play. And notice that we're getting a whole bunch of messages and the log is growing. We have over 1,000 messages and the timestamp is moving forward because time is moving forward as we're in runtime. And I can collapse these messages because they're all the same message. And notice it's just showing how many of these same messages there are. A lot, because we're calling update many times a second. And there's only one or two things I wanted to show you left. So that was what's known as a constant or just a hard-coded value. Let's talk about properties, variables. So I'm going to say this is not a method. It's not a block of code. It's just a variable of a certain type with a name that we can use. So I'm going to say public. I'm going to show you why I'm making this public later. The type of the variable is string. Remember, there's others like integer, floats, booleans, and even stuff relating to the game engine, like game object and Vector3, which we'll see in the next lecture. And then I'm going to call it something like my string. Usually for properties, this is called camel case. You have multiple words. You don't put a space in. You just uppercase the next word, the letter in the word. But they start off lowercase. Usually the methods in the classes start off uppercase. And I'm just going to end it. I'm not going to set it to anything, which means it's just going to be an empty string. It's the same thing as saying this. I'll do that just to make it very clear that it's just being set to an empty string. And if I put it in here, I'm putting a variable into my method, not just a constant, not just a value. Now it can change. Now I get more flexibility in my code. And we're saying, hey, whatever this variable of type string evaluates to at this frame, send it to our log. And if I click play, some things to note. Notice over here in my component object, I now have my string exposed because it was a public variable. The benefit of that is, yes, it's public. It should really be private. But in this development environment, if you make stuff public, it gets exposed in the inspector, which is really easy to modify stuff. Right now, it's printing out an empty string. But if I write stuff in here, the variable gets updated. The value in the variable gets updated, and we're now printing something else to the console. So you can print out what you want. Now this is at runtime, and I'm changing this variable, and it's reflecting in my code. I can unclick play, and notice it reverts back to whatever it was before you click play. It's for kind of like safety purposes, so you can experiment, but it goes back. But say now you know what you want it to say. Well, you can actually enter it. And when I click play, it's now showing that variable. So it's really powerful to make public properties, which are just variables in a class, because I'm just changing it in the inspector, which is one good thing to do. But an even better thing to do is you'll be able to use your code to change it under different situations as you need to. All right, so this ends that lecture on basically creating our first coded object, our first C# script that we made a component object at runtime.